This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. This is Big Data Masters program. In the previous session, what we have seen, we have gone through with uh, big data basics, big data basics, and then we have gone through with Hadoop, like what Hadoop is, and what are the different components. With respect to the components we have not seen in detail, we have gone through with secondary name node, and data node only. So we have seen three components of from the Hadoop perspective. Moving further, what we have seen in our previous session, like if a particular data node is failing, how to work in that particular scenario, like how the Hadoop is going to handle those particular scenarios. If a name node is failing, then what we can do. Okay, we have gone through with multiple aspects with respect to the Hadoop, and that is nothing but Hadoop functionality or different components inside the Hadoop ecosystem. Then we have seen, like if a name node is failing, then the secondary name node is going to take the responsibility and he will be acting as a name node. And there are certain concepts of checkpointing. And what checkpointing is, that is like capturing the previous state, uh, capturing the state of name node, and then like the normal functionality will keep on going. So these particular things we have seen in our previous session. Big data basics, Hadoop basics. Then we have seen, that is fine, different components of Hadoop ecosystem. Okay, functionality, Hadoop functionality. So these particular things we have seen in our previous session. Today, what we are going to see rack awareness and environment setup. These particular things we are going to see, and certain things from the Hadoop components. Okay, so this is the agenda for the day: Hadoop components and rack awareness. Sorry, my mistake. It is rack awareness. Rack awareness and environment setup. These are the three topics which we are going to cover in our today's session. Okay, so I'm going to start with Hadoop components. So what we have seen so far, we have seen three main components: name node, data node, secondary name node. Secondary name node. So name node, that is nothing but master of Hadoop ecosystem. Let me show you. Okay, I'm going to copy this particular diagram, and up to so far this is fine now. Okay, so what we are having different components. Let me rub client. Okay, so we are having name node, and that is nothing but the master node. This is the master of this particular cluster. It is the master. We know it very well. Hadoop is master and slave architecture, and inside this name node is nothing but the master node. It is going to rule this particular cluster. We are having different machines. It might be possible over here we are having 4 node cluster. It might be possible we are having 1,000 node cluster. That is fine. Now name node is going to handle metadata. We have seen it in previous session, like name node is responsible for handling the metadata, and that is nothing but data about data. Like if certain data or some blocks are available in slave node 1 or slave node 2, its information will be available inside the master node, and based upon that particular information we will be able to fetch that information. We are having replication related stuff. That is nothing but that is nothing but in case of a particular node failure, we will be able we will be in a stage to recover that particular information. So that replication, that is nothing but uh, we are having multiple copies of same block into the different node. So with the help of that we will be able to recover the information. That is perfectly fine. So master node, that is going to maintain metadata, and slave node or data node, that is going to handle actual data, or these particular nodes are responsible for processing and storage. So processing and storage, that is the responsibility of data node. Actual processing and actual storage. Processing and storage of data. Storage of data. So we know it very well. Once we are having huge amount of data, there are two challenges: processing and storage. How to store huge amount of data and how to process huge amount of data. So these are the two main challenges once we are having huge amount of data, and the data node is a person who is responsible for actual processing and storage. So with the help of this, we will be able to process and store. Then secondary name node. Like once a particular node is down, once a particular name node is down, then the secondary name node is going to take the responsibility of master node, and then it is going to serve the cluster. So secondary name node is coming in picture once a name node is down, once a master node is down. Okay, so these are the things, these are the component basically. Apart from this, we are having job tracker and task tracker. Job tracker and task tracker. So job tracker, this is running on master node. Available at master node. At master node or name node basically. And task tracker, it is available on data node. Let me mention DN, data node. Okay, or slave node. Okay, so job tracker and task tracker. Now if we are having a particular cluster, then there are two main challenges. There are two main challenges. First one is scheduling the jobs. Scheduling the jobs. And second one is monitoring the job. Monitoring the jobs. Okay, scheduling and monitoring, these are the two challenges once we are working in master and slave methodology. And that is nothing but like aligning a particular task to multiple machines or nodes inside the cluster. Then if a particular task is given to a particular machine, it need to be monitored until unless it is not completed. Once the task is completed, then we must have a particular status that this job is completed, and then uh, we can say this particular task or job is over. So scheduling and monitoring, these are the two tasks which are performed by job tracker. So job tracker, which is responsible for scheduling and monitoring the jobs, and it is available inside the master node. And it is obvious, like if we need to schedule or we need to monitor, then these particular things must be done by the master only, because it is the one who is going to share the status. It is the one who is going to align the resources among the available machines or nodes inside the cluster. So master node is having job tracker, what we can say, and the responsibility of job tracker is to schedule the job and monitor the job. Scheduling is nothing but aligning a particular task to multiple machines. Yes, someone was speaking. Is there any issue? Do you have any query over here?
No, so
No, sure.
No,
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 fine.
Okay, perfect, perfect. So, okay, so what we are having job tracker, and the responsibility of job tracker is to schedule and monitor the job. Then task tracker, and what we can say, these are the actual performer. Task tracker, we know, like storage and processing is done at the data node side, and this particular person named as task tracker, that is available inside the data node. So it is actually performing, it is actually working onto the data, and it is going to provide the outcome based upon the data which is given to this particular machine. Okay, say slave node 1 is having some part of the data, slave 2 is also having some part of the data, slave 3 is also having some part of the data. All of these particular machines will work together and in a parallel way, and the outcome, say, which is given by slave node 1, that is the intermediate output 1, slave node 2, that will be intermediate output 2, and slave node 3, that will be intermediate output 3. Okay, you can think in this particular way, like say I need to add 1 to 10. I need to add numbers starting from 1 to 10. So say 1, 2, and 3, these particular numbers will be given to this particular node, 4 5 6 over here, and 7 8 9 10 over here, and this particular distributions of number, that is nothing but scheduling. Okay, now data node 1 or slave node 1 has completed, it has shared the output, and who is monitoring that particular stuff, like is data node 1 has performed, is data node 1 completed the task. So master node or the job tracker inside it is that is going to monitor. So what I can say over here, job tracker, scheduling and monitoring, task tracker, it is actually working onto the data and providing the output. So we are having 5 components inside the Hadoop one. I'm talking about Hadoop one over here. So far what we have seen, that is with respect to Hadoop one, but over here we are having one challenge. Okay, Hadoop one is having one challenge. Hadoop one. Okay, so that is Hadoop version 1, friends. Hadoop 1. Now, what we have observed, like the task tracker or master node, the task tracker is running onto the master node, and what this particular person is doing, it is scheduling the jobs and keep on monitoring. So it has been observed, once the cluster size is greater than 4,000 nodes, cluster size greater than 4,000 nodes, okay, then Hadoop one was failed. once the cluster size was of greater than 4000 node, then Hadoop one was failed. And this there are certain issues. What are the issues basically? Now, if we are having 4000 nodes inside the cluster, say data node 1, data node 2, and up to 4000 nodes are there, but we are having this particular master, and this particular master is keep on monitoring and scheduling all the 4000 nodes. It might be possible inside the 4000 nodes, we are having 10,000, applications which are running in parallel. It might be possible. Now, if we are having 20,000 and or 40,000, so say 4,000, okay, that much applications are running inside a particular cluster, and after scheduling, this particular person job tracker is keep on monitoring all of those particular application, then uh, it is a difficult task, and the job tracker is not able to perform that particular task, and it was failed. This is the bottleneck inside the Hadoop one. If the cluster size is greater than 4000 node, then it is not able to monitor all of the jobs running inside the cluster. Okay, it was failed because of the issue that it is not able to monitor all of the jobs. Then Hadoop 2 came in order to solve this particular issue. Hadoop 2 came. So inside the Hadoop 2, what was done? This monitoring and scheduling, it has been divided among two persons. Monitoring and scheduling. Let me mention over here inside Hadoop 2, monitoring and scheduling has been divided in two persons. I'm mentioning person, but like that is nothing but machines. Okay. Now, what has happened inside the Hadoop 2 that is named as Jan? Okay. Yet another resource navigator. Okay. Yet another resource navigator. So Hadoop 2 came in order to solve the issue which was there inside the Hadoop 1, and that is nothing but once the cluster size is greater than 4000 node, it was not able to monitor all of the jobs which are running inside the cluster. So inside the Hadoop 2, the concept of resource manager, resource manager, the concepts of resource manager and non node manager came. Resource manager and node manager. Okay, okay, resource manager. Now, if a particular job is coming, we will be discussing in detail at that moment. Once we will be having detailed sessions onto this. Once we will be going to start Spark, then we will be having detailed sessions. But I'm just giving you a hint, like what is happening inside the resource manager and node manager concept. So now, like if a particular person or client is there, then like resource manager that is running inside the master node. So it is going to resource manager. Hey, resource manager, I'm having an application. uh, Application that can be anything like a particular code or a particular program. You can take it in this way, that is an application. So client is having an application and it is going to the resource manager. Hey, resource manager, I just want to do the execution of this particular application. Now the resource manager is having what? Having node managers, or nodes, what I can say, or data nodes basically. So it is having different node manager, say node manager 1, okay, node manager 2, node manager 3, nm3, okay, and that is nothing but a cluster, okay, nm4, okay. So we are having different node managers inside the cluster. So resource manager is going to see what are the different resources available inside this particular cluster. Based upon the availability of resources, it is saying it is going to divide this particular application inside different nodes. Say first part is over here, second is over here, and say third is over here. Third is over here. But before this, there is one concept of application master. This is a certain thing, application master. Application master. So resource manager at this moment is going to run a program on a particular machine inside the cluster. Say on node 5, it is going to run application master named as say am. Okay, so the client came. Let me repeat it once again. The client came, and the client was willing to do the execution of this particular job, and it is asking to the resource manager, like, hey, resource manager, I just want to do the execution of this particular application. Then resource manager is going to start a container, container that is having application master. So it is going to start a container inside one of the node manager. Now the application master is going to check the size of application, the requirement inside the application. Based upon the requirement, based upon the application's requirement, it is going to bargain the resources with resource manager. It is saying, say, hey, resource manager, for the execution of this application, I need to have I need to work on three nodes. Say node manager 1, node manager 2, and node manager 3. Okay, so resource manager is having the details of the complete cluster. It is not saying say node manager 1 or 2 or 3. It is just asking the resources, like this much of resources I want to have, like say 2 core 16 GB RAM. In that particular way, it is asking the resources.
Ashok,
Yeah,
sorry
yep,
to
yep.
disturb
Hmm.
here. Like you told, no,
Hmm.
node manager. Okay, node manager is like
Hmm.
data node. It
Yeah,
is
yeah, these
same
are
with
data
data.
nodes. These are the machines, you can say. Data nodes are
Okay,
nothing but machines. These are
yeah,
also
machine.
machines.
Okay, okay, okay.
Okay. So application master is going to bargain with resource manager, head resource manager, for the execution of this application. I want to have this much of resources. Then based upon the requirement, based upon the requirement and availability. Why I'm saying bargaining? Because it might be possible it is saying, say, I need to have 10 resources, I need to have 20 cores. Just try to focus over here. Application master can say anything, but resource, it is the responsibility of resource manager. It is having the complete control of this cluster, and based upon the available resources, it is going to say, hey man, I'm having this much resources, you just need to do the execution with this much resources. If certain resources are free, then I will provide you the remaining one. Okay, so bargaining is once the bargaining process is done, then the application is routed to the node managers. Now the task of the resource manager is over. That was nothing but scheduling. Okay, scheduling is over. Now application master is keep on monitoring this particular application. It is going to have the interaction with node manager 1, node manager 2, or node manager 4, like, is the task done, is the task done? and once the task is done, it is going to share the outcome to the resource manager. We are having certain other concepts as well over here, like driver and other things are there. Okay, we will be going in details once we will be uh, starting a Spark. So it is going to provide the status. Once it is having status, then the client is informed with the output. That is fine. Now, if we are having, I'm having one question over here. If I'm having 20 applications, if I'm having 20 applications inside the cluster, how many application master will be running inside the cluster? How many application master I need to have?
20.
Try to think and
That that will be decided by resource manager, na?
hmm,
Resource manager will take decision, na? That for
hmm.
20 applications, how many application masters will be required.
But for each application we need to have one application master. What I want to ask over here more specifically, like, it is, or let me explain. So if we are having 20 applications inside the cluster, resource manager is going to initiate 20 application. For each application, one application master is running, and it is the responsibility of that application master to monitor that particular application. And it is not like limited to this particular node. It is going to choose any node which is having the resources at that moment. That particular node will be having the application master program, you can say. And that particular machine will be going to monitor that particular application. Say for application number 5, what we are having, we have chosen node 3 as application master. Inside this we are having certain resources. Okay, and those particular resources are having application master program. Okay, and the the job of that particular program is to monitor the application. Okay,
Okay,
is it
Ashok,
clear?
one question.
Mhm.
Like if
Mhm.
20 nodes were decided to monitor those
Mhm.
20 applications, so those 20
Mhm.
nodes will do actual data processing and storage as well, or just working for the monitoring of those applications?
Yeah, that is a good question. I was expecting this. So
Mm.
what we are having, friends, in the world of big data, we are having heavy machines. Say I'm having 64 core CPU, and say 512 GB RAM. GB RAM. This is the configuration of one machine. You can say node manager 1 is having this particular configuration. Now, what we are going to do, we are going to divide this particular configuration among the 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 smaller, you can say, chunks. What I can say, I will be having different executors or containers. Basically, I'm going to have containers. Containers. So containers. So I'm going to decide the size of container. Say like for each container, the configuration will be 4 core, and plus say uh, what I can say, 8 GB RAM. Okay, 8. Okay, yeah, that will be fine. So 4 core CPU and 8 GB RAM, that is nothing but the size of container. And you can think like probably I will be having for 16 container. I will be having 16 container in this particular configuration. Right? 16 container. Now, say one container is given to application master, rest containers will be responsible for the execution of the task. Right?
Okay.
Clear, Pankaj?
Yes, clear.
Okay. Now, one more thing is there. Okay. One more thing is there. Uh, like it might be possible the data, the application size is very less. The application size is having very small size. Like that is a simple program, say the addition of two numbers, or say uh, dividing or like finding out the factorial. I'm just taking very basic examples. So those programs are nothing but one application. Okay, and if we are if like this particular application master observed that this application is very small, it can be done, the execution of that particular application can be done over here only. So there is no bargaining of resources will happen over there. Okay, there will be no bargaining of resources, and it is going to execute, and then the status will be shared with the client. Right.
Shok, one question here.
Mm-hmm. Yes.
Question is that if suppose this is a 5 node cluster like that, or we want to run 50 machines or 50 application is there. So can
Mm-hmm.
we use one node for multiple application? Can we use for one node for multiple application master
Yeah, that is fine. We can use.
in
We can
container
use.
basis? Mhm.
Yeah, containers. Yeah, like I have used the word container over here, but inside
Mhm.
the Spark, we used to say executors.
Mhm.
Okay, so and like multiple executors are running in order to do the execution of multiple applications.
Mhm. Okay.
Okay,
A different
and
application master is also running in one
yes, yes,
particular.
yeah.
Mhm.
You can think in this particular way. You in your team of software developers, there are 40 persons, and 40 persons are working onto the single cluster. Okay, and 40
Okay, got
persons
it.
are performing the execution of their task or applications. Then based upon the availability, say uh, one user is occupied two containers over here, two containers over here, four containers over here. So remaining containers will be given to the another client or another user. Okay, based upon the availability. Based upon the resource availability, the containers are allocated to the users. Right.
Got it.
Just have a look
Got it.
over here. All of you, please just have a look and ask any if you are having any doubt. And one more thing, once the execution of the application is done inside the application master or container only, then we are having a special word for this particular process. We used to say this uberization. Okay, once the execution of application is done within am, then this is called uberization mode. Uberization mode. This is a special word which is used to describe like once the application is small and the execution is done within the application master. Uberization, right? So all of you just have a look onto this particular stuff. If you are having any doubt, you can ask.
Once job of application master will finished, then it is used for the other execution.
Yeah, then those particular resources, container, those
Yeah.
particular resources will be freed.
read and use for the execution or use for the
Yes,
new
yes, it is
application.
not like, say, if we are having one executor, then it is going to occupy that particular container uh, for very longer duration. It is not like once the execution is done, then the resources will be freed for the further executions.
Okay, thank you.
Uh,
Okay.
so sorry to ask
Mhm,
the one question.
mhm,
Inside the node manager, you mentioned like application master. Okay, what is this
mhm.
application master? I'm little confused about this words.
Uh, Application
Ah,
master is nothing but a program, a software.
okay, okay. It's
Okay.
a software. Okay.
So that is having the responsibility to bargain with the resource manager, and based
Mm-hmm.
upon the allocation or based upon the allocated resources, it is going to uh, run the application over the
Okay.
nodes. Say here the resource manager has given three containers in node manager 1, node manager 2, and node manager 4. It's the responsibility of application master to
Mm-hmm.
align the
Mm-hmm.
resources uh, with the application and keep on monitoring what is happening in with the application in this particular node. Once the
Mm.
application is executed, then it is going to share the outcome with the client.
Yeah, yeah, understand. Okay.
Okay, that is a program only, and try to think in that way. Like, these are machines, but what is running inside the machines? A software is running, which is responsible for these particular things. And a
Okay.
software, we used to say software tool. Okay,
Uh-huh.
whatever.
Okay.
Okay, so that is responsible for uh, the execution of tasks in master and slave uh, paradigm, and then we will be able to get the outcome with low latency, which was not possible with single machine. Over here we are leveraging the processing capability or storage capability of multiple machines to process huge amount of data, right?
Got it. Sir. Got it.
Perfect, perfect. Okay, so these are nothing but the components of Hadoop ecosystem. Okay, and from the Hadoop to perspective, we will be having detailed session once we are going to start uh, Spark. Okay, then we will go through with certain diagrams, and then things will be pretty clear. Okay, so these are nothing but Hadoop component. Let me move with the second topic, that is rack awareness. And let me show you one diagram. Okay, so this is a diagram. This is a diagram of data center. Like, we will be having uh, different machines which will be put together in the form of rack, and then these data centers will be serving uh, like, these are nothing but with different data nodes, what I can say. And these data centers or racks will be serving in order to store huge amount of data, or in order to process huge amount of data. This is the data center from the Amazon side. Same way, like, we are able to we are able to see the data center of Facebook, and I have downloaded these particular images from the Google itself. So this is the data center, but how the machines are maintained? Just have a look over here. So what we are able to see, these are racks. These are racks, rack 1 2 3 4. These are racks. And how we are we are maintaining data nodes over here. So say the rack one. So we are having, this is the diagram for, say, Hadoop cluster, and in this particular cluster we are having different racks. And these particular racks are connected with each other with the help of switches. Okay, so these particular racks are communicating with each other with the help of switches, and they are connected with the internet. With the help of internet, these racks are connected. You can think in this particular way over here, like we are able to see these particular racks inside one data center, but it might be possible, say one rack is available over here. Say I'm running a data center for a big company, big organization, and what I can say Airtel. So Airtel is say having one data center over here in Delhi, another data center in Mumbai, third data center in say Bangalore, fourth data center in say Australia. Okay, so what we are having those data centers, we are having different racks, and it might be possible like one rack is placed in one location, and we have like framed a cluster, and that is having different racks, and these particular racks are geographically apart location. Okay, and these particular racks are communicating with each other uh, in order to serve the purpose, in order to store and process the data. Now, just have a look over here. We are having a name node in this particular machine. We are having a job tracker. We are having secondary name node. We are having a client in this particular rack. So, different data nodes are there. Data node, that is nothing but task tracker, what I have mentioned. Task tracker, which is responsible for actual execution and storage. So, data node or task tracker, that is uh, like we are having multiple data nodes and or data task tracker. And now the main thing is that like if we need to uh, if we may need to like maintain the fault tolerance. Fault tolerance is nothing but if a particular machine or node is down, then uh, like will I be able to recover that particular information which is stored in that particular node. Okay, so you have seen a diagram uh, that is having racks, and racks are having different machines. So what I mentioned, fault tolerance. Fault tolerance as a mechanism to recover information or data. Okay, data. So if a particular node is down, uh, will I be able to recover that data? That is nothing but fault tolerance and capability. So in order to recover the information, what we are having, replication factor. Okay, replication factor. Replication is nothing but we are uh, storing multiple copies. Multiple copies of a particular file will be stored. So maintaining replication. Now, to maintain replicas, that is a very tough task. Now, how to maintain the replicas? If we are going to maintain the replicas, say this particular rack is available in Delhi, and because of certain natural calamities or earthquake is there in Delhi, and this particular rack is down, and if we are having say different data node, that is fine. And we have kept our data in this particular rack, and if a particular rack which is placed in one geographical location and that is lost because of any issue, okay, then we will not be having the access to that particular data, and that data will be lost. So rack awareness mechanism uh, is very important in order to have the fault tolerance capability. Now, this is nothing but how we are going to move the replicas. How we are going to move the replicas inside the racks. Rack awareness, how we are going to move replicas or copies of file. Okay, let me take an example. Say like we are having Delhi network, and Delhi network is storing its data in a particular data center which is placed inside Delhi only. And say they are having the data of last 5 years now because of certain reason or hardware failure, okay, the rack, or because of fire incident in the data center, the rack, the racks which were storing the data, that particular data has been lost. Now we will not be having the access, the fault tolerance is not there. Now in order to like improve the fault tolerance capability, what we are going to do, we are going to move the data in such a way so that like if a particular rack is down, then we will be able to recover the data. Okay, that is nothing but rack awareness, so we are having multiple scenarios in order to store the data. Okay, but one challenge is there, L- so one challenge is there. I'm coming on that particular point, so say approach one, I'm having multiple approaches. Approach one, first approach, what is it is saying, say maintain maintain replicas in single rack, single rack. To maintain replicas in single rack, just have a look. So this particular rack is available in Delhi, and if we are maintaining replicas in replicas is nothing but say copies of that particular file. Say we are having data node, let me mention data node 1, data node 2. Okay, you can think in this particular way, like we are having a capacity, like in a particular rack we are having six machines or six node capability, so we can have six data node only in a particular rack. Now say a replica 1 is there in data node 1, then replica 2, okay, that is nothing but copy, and replica 3 is there. Okay, so we are having a file of say 500 GB data, and that is placed in such a way like replica 1 is in data node 1 of rack 1, rack 1, rack 1. So rack 1, inside rack 1 we are having data node 1 that is having first replication, like 500 GB is available over here, 500 GB available over here, and 500 GB available over here. Three machines are going to maintain the data 500 GB data, so that so that the normal functionality of the network will keep on going. The main benefit of this particular approach is if the data node 1 is down, we will be able to recover the information from data node 4. If data node 4 is down, if like 1 and 2 1 and 4 is down, we will be able to recover the information from data node 6, that is fine. Latency will be low over here, because like say if I'm sitting in Delhi and the rack is available inside the Delhi only, so I will be able to recover the information. Once two nodes are failing, I will be able to recover the information from the node 3 which is having the replica. So with low latency, I will be able to recover the information, I will be able to recover the data. But if the complete rack is down, the data will be lost. Challenge, what is the challenge over here? If complete rack is down, okay, that is a challenge. Latency is low because the data is available on the same geography, in the same geography, in the same rack, and latency will be low over here. That is good. That is good. This is the benefit. So this particular approach is not good because there are chances that a rack is down because of certain calamities and because of different issues. So we are not going to put our data in this particular way. This is not the recommended way in order to move the replicas in single rack only. Okay, so this is approach one. Approach two, what it is saying, move the data into different racks. So what we are having, we are having rack 1. In the same way, we are having rack 2 and we are having rack 3. And rack 1 is having, say, first replica. Then I'm going to move inside data rack 2. We are having 6 data nodes. Say. Okay, and in the same way, and say replica, second replica is available over here. In the same way, what we are having a different data node. And say the replica 3 is available over here. Okay, replica 3. Okay, so approach to is saying maintain replicas in different racks. That is good. Like if the issue is with this particular rack, okay, or data node, then we, if the issue is with this particular rack or data node, then we need to like we are having data in rack 2. If there are certain issues, then we will be able to recover from this particular rack. Okay, that is fine. Like maintaining data benefit. Like benefit, what is the benefit? Maintaining data in different rack and maintaining data in different rack, and fault tolerance will be good. Will be good. Good in which scenario? Like if the rack 1 is down, then we will be able to get the data from rack 2 or rack 3. That is fine. But challenge, one challenge is there with this particular approach. Can anybody tell me what is the challenge?
Latency.
What? Latency.
Latency.
That's perfect. Yeah, latency will be high. Yeah, because we are going to communicate. Like say, one rack is placed inside Delhi, and another is say, placed inside Australia, and third rack is placed inside say England. So because of the data movement, and try to focus onto the latency. This is the KPI for us. Latency is the KPI for us. If like we are working in a big data world, then we need to think in such a way how we will be able to minimize the latency. Okay, because we will be working on huge data, and with any technique, any concept, any mechanism, if you are able to minimize the latency, then you have justified your job. So we will be looking for the minimization of latency. That is fine. So latency is a challenge, because if this particular rack is down, we need to move the data. We need to uh, uh, get the data from the rack 2, which is placed into the different geographical area. Okay, so that is the second approach, and we are not going with, say, approach 1 and with approach 2 as well. Then we are having third approach, approach number 3. So in this particular approach, what we are going to maintain two replicas in one rack. Two replicas in one rack. Say R2, R2. So two replicas in one rack, maintain two replicas in one rack, and third replica in different rack. So over here, what I have mentioned, we are going to maintain the replicas, two replicas in one rack and third replica into the another rack. And this particular approach is good because what we are having, if like it is not like possible that every time we will be having challenge with rack. Rack is failed once we are having the issue because of, say, fire brand, or natural calamities, earthquake or flood. So in that particular way, the complete rack will be down. We will not having the access of that particular rack, but we are having the more chances of node failure. Hardware can be corrupted. For the nodes, like, we are having the higher probability. So if a data node is down, these are nothing but the hardware. And if a data node is down, then we will be able to recover the information from uh, data node 3. Okay, so in this particular way, we will be able to recover the information with low latency and within that particular geographical area. But if the rack 1 is failing, that means like entire geographical area is having issue. So at that moment, what we are going to do, we are going to like move the data from the another rack. So I have taken the example like racks are placed into the different geographical area. That is like in order to give you an idea that, like, if the data movement is more, then it will be going to take more time. So latency will be more. But it might be possible like we are having racks, different racks inside the same data center. At that moment also, we will be having the latency challenges, because these particular racks are communicating with each other via internet. Via these particular switches, these particular racks are going to communicate. And once the communication is happen, once the the movement of data is happening via switches, then definitely that will take time. Okay, so it is not like, say, every time we are having the racks placed inside the different geographical area, but to
Uh,
understand the concept in a yes,
Inside the rack
please,
also latency is high in this case.
inside rack,
Ah,
yes.
uh,
Actually, what is happening, if you are processing the data with a big machine, okay, you can think in this particular way. Say I'm having one machine, one machine, one machine, and if the entire data is available, complete data is available in one machine, then what will happen? It is going to process and provide you the outcome. At this point of time, the latency will be low, because each and everything is happening within that particular machine, and that particular machine is capable to handle the data. Okay, and we are having certain tools like say PostgreSQL, MariaDB, okay, or RDBMS. RDBMS. That is Relational Database Management System. Oracle, you can Oracle, MariaDB, Postgres. Okay, uh, uh, and different RDBMS are there. Say from the Amazon side, we are having RDS, and each and every organization is having its own type of RDBMS, that is Relational Database Management System. One thing is there, RDBMS are working in a monolithic way. We are going to install RDBMS in a single machine, and then it is going to process your data and provide you the outcome. And in the like in the traditional way or traditional fashion, or in the earlier days, say 2000 to 2010 to 15, what we were having monolithic machines, and we were processing the data, and we are having low latency, because once we are having huge data, okay, once the data size is huge, then what we are going to do, we are having multiple machines in this particular way, like uh, then we are going to divide the data into different machines, although like these particular machines uh, are going to process one data huge, these particular machines are working in that way, like once the data is used, at that moment, like these particular machines are working on some part of data. Each machine is not working on like complete data, because like if we are allowing say file 1 enter file is processed, then that is the monolithic way. So part 1 is work completed by this particular machine, part 2 of a data is completed by this machine, part 3, and these particular, then we will be having intermediate outcome, then further joined together, and we will be having final output. So in this particular way, like the communication between these particular nodes via master machine, okay, and dividing the task, and then arranging the machines, and then aggregating the data from the different machines, those particular things are there, and because of that the latency will increase. Okay, if I'm processing with one machine, then that is fine, like each and everything is available in one machine. But if another machine is coming, then the communication will happen from this particular switch. This particular switch is placed in order to have the communication among these particular nodes, like data node 1 is going to communicate with this particular node in this particular via this particular switches, okay, switch. And if like this particular rack need to communicate with this rack 4, then it is going to communicate with this particular switch. So inter rack communication is happening with this switch, and intra rack communication is happening with this particular switch, right?
Mm.
Making
Right.
sense? Okay, so
Okay. Mm.
this is the challenge, and this is the preferred approach. We are going to keep two replicas in single rack, and third replica into the another rack, because two switches are coming in picture once we are having inter-rack communication. Okay, if this particular the complete rack is down, then that is fine, we will be able to recover. But if we are having the issue with data node only, then we will be able to recover this particular data from the data node 3, which is available in this particular rack only. Okay, and this particular mechanism, we can say finding out the shortest distance, finding out the shortest distance, because like we need to maintain the latency, we need to minimize the latency in order to recover the information. So we need to find out the shortest path, and like over here the shortest path is like if we are having the issue with data node, then we can find the data, we can get the data from the another node. But if we are having challenge with rack, then definitely we need to move, uh, uh, we need to take the data from the another rack. So that is how we are going to maintain the rack in order to minimize or maintain the data inside the rack in order to minimize the latency. And this particular concept is called rack awareness, how we are putting the data inside the rack, inside the racks. Perfect. Clear so far?
Yes.
Yes, Ashok.
Okay, fine. Okay, that is fine. Now another concept is there, availability. From the telecom, for the telecom guys, availability, that is the non word, right?
Yes,
Availability.
absolutely. Yes, yes.
Okay, so same is here only, and the definition is also like somehow near to the telecom. So availability, that is nothing uh, but but uh, how we will be able to have the data if a node is failing, somehow near to fault tolerance, availability. So at the telecom, what we can say, if a particular node or site or uh, cell, okay, is having fluctuation, that is not serving, so what we can say, that is not available. And for that much percent, like if it is down for 12 hours, then we can say the availability is say 50%. If it is available for 30 minutes in an hour, so we can say availability is 50% only. So uh, over here, high availability, high availability, whenever the data, whenever you require the data, it must be available, that is high availability. Or in another words, like the nodes inside the cluster must be in running condition, and they will be serving the 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 client. They will be, they are in the condition to serve the clients. So once a client is going to demand something, once a client want to run a particular code, or once a uh, like client is willing to store some data, once a client is willing to fetch certain data from the cluster, it must be able or capable to serve that purpose. So in order to have high availability, we are having certain scenarios or certain stuff inside the big data world. First one you have gone through with that, that is nothing but checkpointing. Okay, checkpointing. So checkpointing, what we have seen with respect to the checkpointing. Okay, so checkpointing, we have seen checkpointing over here, and that is happening every 30 second. Every 30 seconds the checkpointing is happening. And why we are going to perform checkpointing? If the primary node, name node is down, if the name node is down, in case of its failure, the secondary name node will be able to take the responsibility of primary name node. And why why secondary name node need to take the responsibility? Because if we need to keep the cluster in running condition or state, then it must have the information about the metadata, and which is placed inside the shared memory. So from the shared memory, the edit log and fs image, these particular files are there. It is going to uh, copy these particular files inside from the shared memory, and then it is going to serve the clients. Okay, so checkpointing we have gone through in detail with respect to the checkpointing. That is nothing but it is going to copy or the files from the primary name node, and it is going to club these particular files together in order to create an image, and that is fs image ckpt, or that is known as checkpointing. Now this particular fs image ckpt file is moved inside the shared memory, and it is going to replace the older fs image. So in this particular way checkpoint is happening, and it is uh, like responsible, or with the help of checkpointing we will be able to have high availability, right? So checkpointing is a way in order to increase the availability inside the Hadoop ecosystem, right? That is the first technique. Clear? All of you fine
Yes,
so
yes,
far?
yes.
Okay. So first one is checkpointing, and with the help of checkpointing, we will be able to increase the availability. Now, another another scenario or another stuff what we are having in order to increase availability, that is quorum of general manager. Quorum of general manager, try to focus onto the diagram. Okay, so quorum of general manager is the second technique in order to increase the availability. Now over here we are having the client, and client is keep on accessing the cluster. Over here we are having active name node, nn stands for name node, and what is happening over here, like active name node, with the help of active name node, like this particular client is connected with the cluster, and we are having these particular nodes and data nodes. Now previously the shared manager, like what we have seen, we have seen shared memory. The the logs are uh, the logs were written inside the shared memory, but over here the quorum of journal manager is used. That is nothing but multiple machines in order to keep the records what is happening inside the cluster. We are having multiple nodes over here, that is general node 1, general node 2, general node 3. These particular machines, this particular small cluster is going to keep the data what is happening inside the cluster, with respect to this active name node. Like say uh, in this particular cluster, just try to think, this is the cluster. In this particular cluster a lot of things are happening. We are having a big cluster, and with respect to the big cluster we will be having big metadata, huge metadata. Okay, so like these particular nodes are keep on recording what is happening inside this particular cluster. Now we are having one FC, that is failover control. Okay, failover controller. Now and another component zookeeper. Zookeeper JK, that is nothing but zookeeper. Now like once each and everything is fine, the active name node is in working condition, then uh, it is having the connectivity with zookeeper. Okay, it is having the connectivity with zookeeper is keep on, that is nothing but a manager which is keep on uh, uh, tracking, like is the active node is name node is available or down. Is the active name node available or down? This is resource tracking mechanism zookeeper. It is going to keep on track what is happening inside the cluster. This is zookeeper. This is done by zookeeper. Now the standby node or secondary name node, okay, that is standby node or secondary name node, that is like same concept, like we are having a standby machine. Okay, once this particular name node is down, then like this particular connection will be lost. Okay, once the zookeeper is able to see like the connection from the active name node is down, and then it is going to inform standby node that you need to serve the purpose, you need to serve the cluster, and it is having direct access to the quorum of general manager instead of like say single file or two file. Now it is having the access to the complete quorum of general manager. It is having the entire information. This particular connection is broken at this moment. Once the active name node is down, now standby name node is going to take the responsibility, and then like it is going to serve the cluster, huh? What we are able to see over here, data node, like each and every data node is going to like send the heartbeat message. With the help of that, like it is going to have the information that a particular data node is inside the cluster, or data node is live or dead, huh? So heartbeat message that is with respect to the data nodes, and write log, edit log, that is with respect to the name node, huh? Like what is done by name node, that is recorded inside the edit log, and secondary name node is having the access to those particular edit log file. And once it is down, the zookeeper is going to inform the standby name node, and then it is going to take the responsibility, and the cluster will be keep on running. There will not be any impact of name node failure. Standby name node is going to take the responsibility. That is quorum of general manager. Instead of like single shared memory, we are having multiple resources or multiple nodes clubbed together in order to serve the purpose. Okay, just have a look and ask if you are having
Hello.
doubt.
Yeah, I have a query, Ashok.
Mhm.
Hello. This JK is going to serve a purpose of checkpointing here.
No. Over here, checkpointing is not happening. Each and everything is recorded, live recording, or is written inside the general node. Okay.
Okay,
Each and everything
okay,
is written inside these particular nodes. No checkpointing is required over here.
fine. And
Checkpointing
this
is the previous
heartbeat,
step.
okay, and this heartbeat is provided every time to both active NN and standby NN, whether the active NN is up or down, irrespective of that.
No. Once this particular active name node is down, then to whom they are going to provide?
Okay, then heartbeat will be only provided to the active node or standby node,
Yeah,
right? Not both of them.
actually,
Okay,
what is happening
Ashok.
once yes, please ask.
Yeah, I'm just asking, what are the exact benefits of this using QGM over checkpointing? That why it is better than checkpointing?
Actually, like shared memory, what we have seen, that is limited to 128 MB only. The size is very less.
In case of checkpointing, na?
Yes. The size of
Okay.
the FS image file is very small, around 128 MB, and each and every moment, if like the size is going uh, to be more than 128 MB, it is going to refresh itself, and uh, like the previous one will be deleted. What we have seen over here, like it is going to replace this particular FS image with the newer one,
Newer
right?
one. Okay.
Replacing is happening over here, so the size limitation is there, huh?
Okay.
Okay. And I think okay, so once the active name node is down, working, okay, and secondary name node is also working, that is in working condition. So these particular nodes, both of these particular nodes are consuming the heartbeat message, Okay, that is nothing but status information. Hey, name node or second standby name node, like I'm live inside the cluster. This is that particular message only. Once this is down, then with these particular heartbeat message, which is sent by these particular data nodes, it is start acting on those particular heartbeat message. Now the scheduling each and everything is done by standby name node. It will be the name node, primary name node, if this active name node is down. Okay, then it is going to react on these particular messages. It is just like if active name node is live, then it is just keep on listening those particular messages. It is not reacting those particular messages. Okay.
Okay, Ashok, one more question. Once this
Mhm.
active node is down, now
Uh-huh.
secondary node is reading these edit log from this QGM.
Mm-hmm.
Now, after some changes, this standby node will write the edit log into this QGM, na?
You can think in this particular way. You can think in this particular way. Like this is a memory, or this is a location basically, and it is having the access to read and write. To read and write. Writing, like, say, if it is going to store something, but the client, if the client is going to ask something like, I want to have this particular data which is stored in this particular cluster, then active name node is also going to refer the write log. Like, that is nothing but metadata. That is nothing but certain addressing. It is also going to refer, okay, this is the address where the data is placed. Okay, and from that particular data, it is going to provide the information like, hey client, the data is available in these particular nodes, and then the client will be communicating with those particular nodes directly. Okay,
Yeah, actually, I
just have a
just
look.
want to know that once this active node is down, then this
Just a
secondary
minute.
node
Just,
will come into the picture.
I'm coming. Give me a minute.
Okay, okay, okay.
Yes, Pankaj. Tell me. Pankaj.
Yeah, yes, yes, yes. I am asking that once active node is failed, he
Mm-hmm.
has shared some status with the QGM. Okay,
Mm-hmm.
now secondary node is active. It will read
Mm-hmm.
the current, you can say, edit log from the QGM. Okay,
Mm-hmm.
once active node came up, at that
Mm-hmm.
time, active node also has to take edit log from the QGM, na, that what is the current
Mm-hmm.
status where this
Right.
secondary node will stop. So
Mm-hmm.
at that time, secondary node will also write edit log to this QGM, na, so that
Yes,
when
yes,
active
these are the
node came up,
both direction
okay,
stuff.
okay, yes, yes,
Both
yes, yes, yes,
direction.
okay,
Like, it is mentioned in this particular way, like to give you the understanding. Once a active name node is down, then how the flow will happen.
okay.
Okay,
And
but like,
when it came up, then it will reverse. Like secondary node will write edit log to the QGM, and active node will read those edit log from the
yes,
QGM
yes,
in reverse.
yeah.
Okay.
Then further, what will happen? Say the standby name node converted to the active name node.
Yes,
Okay,
yes, yes.
after some time, like we saw that the name node which was acting as an active name node is also available inside the cluster. At that moment,
Mm.
the admin is going to decide, like uh, are we going to make it a secondary name node, or are we going to add another node in order to make the node a secondary name node, or are we going to take some outage in order to like serve or solve these ambiguities? The ambiguities in such a way, it might be possible the active name node is having the higher configuration which was down, and the standby name node is having the lower configuration. That might be the case.
Okay.
Okay, stepney we used in car,
Yes.
that is required in order to serve small purpose.
Yes. Yes.
Okay,
When active node is
okay,
fail. Yes.
yeah. So
Okay.
it is depending upon us, like are we going with that step name or are we going to
Change
to
back
change it?
to yes. Yes.
Okay. So that is the
Okay.
same thing what we are able to see over here, right?
Yes. Yes. It's okay.
Okay. Another another thing is there. Okay. So in some cases, what we are going to have, we are going to attach. So first one is checkpointing and form of journal manager, QJM. These are the basic things, and if we are going to correlate it with our day-to-day activities, we will be able to understand the concept. So column of journal manager and attach external hard drive. Okay. So although this is not the not the preferred way, but in some cases, we what we are going to do, we are going to attach the external hard drives. External hard drives, what these particular hard drives are going to do, uh, with the help of these particular hard drives, we are going to record the data, like metadata, what is there and what is we are having, or like we used to keep these particular hard drives uh, accessible to multiple machines, and it will be connected through, say, through internet, with multiple machine, it will be shared with the multiple machines. So if like a particular node is down, then we are going to read the data from these particular hard drive, although these particular hard drives are uh, having somehow high latency, because it depends like where we are going to put these particular drives, and sometimes like we used to keep the backup of the data. Okay, and based upon the use case, based upon the severity of the data, like the data on which we are working, we are going to take the backup and all, and these particular things are going to increase the availability, right? So attach external hard drives to to store data. Okay, it can be in different ways, like are we going to store raw data over here, are we going to store process data over here, are we going to store the metadata over here? It depends, okay, it depends. The main thing is that, like, we will be able to recover the data on which we are working, so by attaching the external hard drives to store data, we will be able to recover the information or data which is placed inside the cluster, right?
Okay. Ashok, these external hard drives are attached to the racks itself, or
No, 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 no. uh, Say, like, what I can say over here, and just have a look, so over here, what we are having nodes, these are nodes, these nodes are nothing but like machines, we can say
yes.
attach one hard drive to data node 1, okay, uh, hard drive 1 to the job tracker, hard drive to the secretary name node,
Okay. To each
depends on.
okay, on machine itself we can attach these. external
Yeah,
hard drives.
if like this particular node is down, then from that particular hard drive we will be able to recover the data,
Recover
right?
the data. Okay. And this QGM also a separate machine, na?
Yeah, QGM like general node 1, 2, 3. This is a small cluster, what I can say.
Okay, these
Okay, that
JN
is
1, 2, 3, those are separate machines.
yes, 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 yes.
Okay.
Perfect.
Okay.
So
So,
so
is there
far what
any
we
mechanism to uh, how these different journal managers will communicate with each other?
uh, over here, like we are not having the master and slave methodology. This is say like if this is having initial information, then like the information or data has been increased, we have added another one. Okay, and these are connected in a particular network topology, say mass network or ring topology. Okay, or these are connected with bus bar and all, huh? So over here master and slave architecture is not there, but with the help of certain interconnect network topologies, these devices or these nodes are connected and these are communicated with each other, huh? We can say distributed mechanism is there, but master and slave methodology is not there over here, huh? Data is
So,
distributed among different
how
machines.
secondary node will came to know that from which node he has to take the current status edit log?
Basically like over here timing and you can say data related stuff, or like say the c- the client is going to ask, say I want to have this particular data with respect to this, which what data metadata is there, you can think in this particular way, like encryption decryption, like for a particular key, for a particular lock we are having a key, so in that particular way, like the data is being captured, you can say certain algorithms are written in order to track that particular data. Like you can think in this particular way, like a particular person is going to make a call, and with the particular person we are having certain list, gray list, black list, white list, so from where we are going to keep, like we are having a central repository. From that repository we are going to repo, we are going to map this particular subscriber, and from that particular repo we are able to get the information, is it bad and or is it like a good client, good customer, so from that particular way, from that particular those particular encryption decryption keys, that is going to track the data. Okay, different algos are there in order to track,
Oh, okay.
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 So you can think over here, like say these are not connected with each other, over here data nodes are connected, these are inside the cluster, okay.
Okay.
Although this is a cluster, and like these are connected with the ring different topologies are there, okay. So they can be connected with different topologies, and like it is having the status information, like it is writing, so it is able to read that particular data, it is able to consume at that moment only, okay. Just this particular connection is there, which is playing a critical role. It is saying, say like if it is not able to get the heartbeat message from the active name node, it is going to say you will be acting as a name node from this particular moment, then it is having the data, it is reading that, it is consuming that particular data, but it is not reacting to that, now it will start reacting, and it will be going to serve uh, from the messages which it is getting from the heartbeats, it will start working on the particular message or status, It is having the entire information real in time, right?
Yeah, it's okay.
Perfect, perfect. So, QJM attaching external drives and checkpointing. These are the ways in order to increase the availability, and that is nothing but like the way how we will be able to recover the information. Perfectly fine. Now, the last topic for the day, that is environment setup. Environment setup. Now, we have gone through with the concept like Hadoop and its component and uh, like the functionalities, how these particular components are working, and then how we will be able to recover the data if the name node is failing, data node is failing. What are the different ways to increase the availability? Yeah? But where we are going to do these particular things, and so we need to have certain software, certain tools we need to have, and I'm going to share these particular things with you all. And from like start before tomorrow's session, you just need uh, to come up with the environment setup so that we will be able to proceed with the practical, Anna. Now we are going to move with Hadoop, and Hadoop is having three main flavors. Hadoop, what we can say, distributions. So Hadoop is given by three organizations: Cloudera, Mapper, and Hortonworks. So recently, Hortonworks and Cloudera merged together, and we will be having Cloudera only. And these are the providers of Hadoop. Like how you will be able to set up the environment. So we are having three main providers, and these particular providers are providing the Hadoop. This is the open source, you can say, community open source tool, and what these particular organizations are doing, they are clubbing Hadoop with some other applications or tools. So we will be having an ecosystem, and an ecosystem like for the execution and storing and processing of our task. So we are having different, you can say, providers which are providing uh, Hadoop with different components. So one of them is Cloudera. We will be moving with Cloudera, and how to set up the environment, like what you need to do. You need to have at least this much of configuration in your machine, at least 8 GB of RAM, and it is good to have, like if you are having 16 GB RAM in your machine, but at least 8 GB RAM is preferred, and more 50 GB disk space, that is preferred, and these are nothing but the hardware requirement. Then virtualization software. So before downloading or having the Cloudera Quick Start VM, we just need to have the virtual box, and from this particular link, we will be able to install the virtual box in our machine. And once the like virtual box is there, then from this particular link you will be able to download Cloudera Quick Start VM. And once you are going to download, like it is almost 5.6 GB file, okay, it will take some time. Then you need to import this particular file inside the virtual box. Now Hadoop is available, or Hadoop is working good on Linux operating system. operating system. Now, in our machine, we are having Windows operating system. Then how we will be able to install a software which is working on a Linux operating system? Like, so let me remove Go down. Hadoop is working on Linux operating system. Then what we are having? We are having VirtualBox. VirtualBox. So VirtualBox is doing what? It is providing you an environment. It is going to provide you Linux kind of environment so that you will be able to import Hadoop over there, and then you will be able to work on Hadoop. So once you are going to click on the link which I have shared over here, this particular uh, website will open, and then you need to download VirtualBox. So for say Windows host, Mac host, Linux distributions, so based upon the distribution, say we are having the Windows host, so I'm going to click onto the Windows host, and it is going to ask a path like where I'm going to store. So in my machine it is already there. Okay, and then what you need to do, you just need to proceed with the normal installation steps. So once you are going to download, then it will look like this, VirtualBox. Okay, VirtualBox. So VirtualBox, you just need to download VirtualBox, and after installation VirtualBox, it will look like this. Oracle VirtualBox. You just need to proceed with the normal installation steps, and then it will be available. It will be installed in your machine. So it will look like this after the installation. Then the next step, what you need to do, you just need to click on to the second link which I have copied inside this particular slide, PPT itself. Okay, once you are going to click on to this, then it is going to ask you, it is going to provide you like a file that is of say Cloudera Quick Start VM 5.1.13. Okay, and you just need to import this, you need to download this particular file, and after downloading you need to extract this. So once you are going to download, it will look like this. Uh, hmm, Cloudera. Okay, so once you are going to download, it will be a zip file. You need to unzip, and then you will be having two files over here. Cloudera Quick Start VM, VirtualBox, and Disk One. So you will be having two files. Once you are going to extract the file after downloading from the link which I have mentioned in this particular slide. Okay, now what you need to do, you just need to import this particular file. You need to click in, you need to import that particular file inside the virtual box. So you need to click on file, then import appliances. Okay, and you need to provide the path of downloaded file. Okay, let me show you. Okay, so say this is the extracted file, Cloudera Quick Start VM. So you just need to import this particular file. Okay, click on open, and then you will be able to import. So it will ask certain things. It will ask certain things like the base memory and processor. Base memory and processor. Once you are going to import this particular file, it is going to ask base memory. So at least you need to mention 8 GB of memory over here. I have given 12 GB to Cloudera Quick Start VM. Okay, and processor to processor I have given. So based upon the available processor, probably like nowadays we are having 4-core CPU, so 2 cores we are going to give to the Cloudera Quick Start VM, and then you need to just click and then the import will start. That will take 5 to 7 minutes, and then you will be having Cloudera Quick Start VM in your machine. So I'm going to share these particular links and slide with you all. So try to download and try to import the Cloudera Quick Start VM inside the virtual box. We will be having certain settings. So in tomorrow's session, we will be going through with those settings, and then we'll start working onto the Cloudera Quick Start VM from tomorrow onwards. That's it for this particular session, friends. If you are having any doubt, you can ask. Gaurav, Vikas, Pankaj, Rohit, Vandana, Rahul, Kapil, anything that you want to ask, friends.
Right now, no queries.
Nothing so far. Things are clear set.
Nothing.
Okay, then I will share the slide. You just download the Cloudera Quick Start VM, import download the VirtualBox and import the Cloudera Quick Start VM by mentioning 8 GB RAM at least. You need to mention in MBs, so it will be around uh, uh, 8096, I think. Okay, so you just need to give that much of memory and 2 core at least to Cloudera Quick Start VM, and then from tomorrow onwards we will be going through with the commands and all. That's it. Thank you. Thanks for joining. Let me stop
Okay.
recording.
Yes.
Thank you,
Thank
Ashok.